This is the second part of 12.2 and graphing rational functions. And it shouldn't take too long. We're just going to graph a function with all of the pieces of the rational function a, h, and k. So we're essentially going to graph y equals a divided x minus h plus k with all the different pieces, and then we're going to spend the rest of our time on a word problem. So the first part of this is just to look at it and maybe identify the asymptotes of the graph. And what we saw before, if you look back at yesterday, when we did plus k, we noticed that the whole function went up from 0 by k. So we know that that vertical, horizontal asymptote, excuse me, the y value. So when we have, let me just put the graph here so it's clear. When we have a function like this, right, your base parent function, and we're moving it up from this asymptote here, which is the y-axis, which is y equals 0, and we're moving it up by k, right? Our asymptote is going to be y equals k, okay? And that is going to be our horizontal asymptote, right? In the same way, and I really, if I'd been consistent, I would have done it in green, but in the same way, when you have x minus h, we noticed that moved things side to side. And when that number was 2, we noticed that the asymptote went from x, right, which was x equals 0, and it moved over to x equals 2, right? It moved to here, where you had an asymptote, right, where x equals h. And so we're going to see how that's going to make it much, much easier for us to graph if we can identify those asymptotes. So that's going to be the goal here as we graph this. Y equals, and we're going to have 2, so we have an a value of 2, which means there's a stretch of 2, right? X plus 1 and minus 3. So what are we going to learn if we use this as our example? Well, if k, right, this value is going to be this asymptote, this is what that moves it up from y equals 0, we know that actually in this case, that k value is going to be negative 3, right? So this means our new asymptote, so we're going to have an asymptote of y equals negative 3, right? This is the asymptote, which is horizontal. And it goes right. And here we have the number 1. And so we can see this h value has to be negative 1. Remember that, because since the base equation is x minus h, to get x plus 1, this value has to be minus 1. That makes sense to everybody? X minus h, so since whatever is here, when we had the value of 2 for h, it moved it to the right by 2 because h was 2. If I had a negative 2, it would move it to the left, and I'd end up with x minus negative 2, so x plus 2. This tells me I have a value of negative 1 in order to get x plus 1, since the base is negative, okay? That means this is my other asymptote, which is my vertical one. That is really helpful when I'm graphing because it helps me decide what quadrant, right? If x is negative 1, I know that it's going to be in this direction, negative 3, so everything is going to be shifted slightly towards that third quadrant. So when I draw my graph, I really want to make sure I have more space, right? Not all, but more space in this direction. Okay, so let me do my horizontal asymptote. So I'm going to go, let's see, -1, -2, -3. So I know my first asymptote is going to be here, right? Y equals -3. So again, asymptote is the value that nothing can touch. That's what our hyperbola is going to be get organized around. And the other is my vertical asymptote, which I got from here. If this is +1, this means it's -1. So if I'm putting my numbers in, -1 is right there. So this is going to be my vertical asymptote right here. So x equals -1. So I have those in place, and what that tells me is now this is not a reflection because it's not negative, right? My a value is positive. That means my hyperbola is going to be somewhere here and there, right? And so that's going to help me because as I'm choosing my numbers to graph, then I'm not going to choose wild numbers. It's going to take me a lot faster to graph because I know where I'm looking, right? So since I do know now where I'm looking, right, I know, of course, that -1, x equals -1 is not going to work, but I do think I can use 0. So here I'm going to start my table. Okay, I'm going to start the first half of my table, and I'm going to put in, let's see, I'll put in 1 for x. 1 plus 1 is 2. 2 divided by 2 is 1. 1 minus 3 is -2. So I have 1, -2 right here to graph. Let's see, what can I put in that would be helpful? Let's see. Let me put in 3. 3 plus 1 is 4. 2 divided by 4 is 1/2. 1/2 minus 3 is -2.5. So 3, -2.5. And I can see that's working out nicely because I'm approaching my asymptote, but I'm not there yet. And I realize I have to have a number that's approaching this asymptote here. So I'm going to put in 0 because 0 will work. 0 plus 1 is 1. 2 divided by 1 is 2. Minus 3 is -1. So I put in 0, I get -1. And there I can now draw the first branch of my hyperbola y equals 2 over x plus 1 minus 3. I'm going to actually draw a second table over here, right, to avoid confusion. And I'm going to try then to find the numbers that are going to draw the second branch, which is going to be somewhere down here. So I'm going to pick -2, just because it looks like that's the right direction to go in, since I can't use -1. -2 plus 1 is -1. 2 divided by -1 is -2. Minus 3 is -5. So it looks like I have to go down a little bit. -2, -5. Let me put in -3. -3 plus 1 is -2. 2 divided by -2 is -1. -1 minus 3 is -4. So -3, -4. And that's good. I can see that, again, that branch is approaching that y equals -3 asymptote. So if I could just find a value here, then I could finish in the other direction. So it looks like I should find something between -1 and -2. So I'll do -1.5. -1.5 plus 1 gives me a -0.5. 2 divided by -0.5 is like multiplying by -2, so -4. -4 minus 3 is -7. So -0.5 and -7. Have to add numbers, and I now have a good, accurate second branch for my hyperbola. So if you look again, you can see that when you look at a rational function, this number here, k, is going to tell you this is going to be a vertical translation, and this is going to be my asymptote, right, on the y equals -3. This is going to be on the x side. This tells me I'm going to have x equals -1 right here as my vertical asymptote. Because this is a little bit complicated, let's do one more just to get comfortable with it. And I'm going to graph, let's see, I'm just going to pick something at random. Y equals 1 over x minus 2 plus 1. And I'm picking low numbers to make it easy. So what does this tell me? Well, this says that my horizontal asymptote is y equals 1. Right, this is going to be my horizontal asymptote. In other words, it's going to raise the whole thing by 1. K moves everything up and down, remember? And this means I have an x equals 2 vertical asymptote because I've moved everything over to the right by 2. So this tells me that I'm actually going to be much more up in that quadrant, so, but not all the way. So I'm going to make it a little bit in that direction, but not entirely. And let's see, I'm going to do 1, 2, 3, 4, 1, 2, 3, 4. Okay. So my vertical asymptote, x equals 2, right? Because what that means is I'm moving everything over to the right, right? This is moving things right or left. If you remember, h is moving things right or left, and this 2 stands in for the h. So this is my first asymptote, x equals 2. And my second one is going to be y equals 1. Right here, right? Y equals 1, so that's my other asymptote. Everything just approaches those, but never hits it. Putting those asymptotes makes all the difference, because once you do that, you can see right away where your hyperbola is going to go. It's either going to go here and here if the number up here is positive, or it's going to go here and here if it's negative. Let's do our table. If x equals 2, oh, I can't use x equals 2 because that's my asymptote. So I'm going to try x equals 1 and x equals 3 and go from there. X equals 1, I get 1 over 1 minus 2, so -1 plus 1 is 0. So I guess I started on my left branch. And if I put in x equals 3, 3 minus 2 is 1, 1 plus 1 is 2. So 3, 2, I'm starting the opposite side. So I didn't mean to do this, but I'm getting my reflection. Let me see what happens if I put in x equals 4. 4 minus 2 is, so I get 1/2 plus 1, I get 1.5. 4 and 1.5, and that likes, and I'm going to try between 2 and 3 to see if I can get the end part of that branch. So I'll get, if I put in 2.5, 2.5 minus 2 is 1/2, 1 divided by 1/2 is 2, plus 1 is 3. So I'm going to get this, and there is my branch up here, and I'm going to now finish this branch over there. So I'm going to try a number between 1 and 2. So let me try 1.5. I did 2.5. I'll try that. 1.5 minus 2, I get -1/2. 1 divided by -1/2 is -2, plus 1 is -1. So I'm down here. And last, let me try 0. I haven't tried 0 yet. And it looks like it will work. 0 minus 2 is I get -1/2, plus 1, I get +1/2. So 0, +1/2, and then I have the 3 points to do this other asymptote down here. Okay, so that kind of goes over how to graph these, and I did a second one. Did not intend to, but I realized this is hard, and I wanted to give you 2 examples. I'm going to stop here and then restart to do our word problem, and that will be ending the lesson.